The future is here, and it's far more groundbreaking than you think. 7 emerging technologies are set to redefine our world. For example, generative AI. Generative AI is a form of artificial intelligence that creates new content by learning patterns from vast datasets. It uses deep learning, particularly neural networks, to analyze text, images, or sounds, identifying structures and relationships within them. Unlike traditional AI, which follows fixed rules, generative AI predicts and generates new data by sampling from learned distributions. Large language models, for example, process billions of words to understand grammar, context, and meaning, enabling them to write coherent text. Image generation models use convolutional neural networks, CNNs, to capture textures, colors, and styles. As these systems evolve, they become increasingly capable of producing realistic and original content, pushing the boundaries of human-AI collaboration. Quantum computing. Quantum computing is a revolutionary field that leverages quantum mechanics to process information in unprecedented ways. Unlike classical computers, which use bits as 0 or 1, quantum computers use qubits, quantum bits that exist in multiple states simultaneously due to superposition. Qubits can be physical particles like electrons or photons, manipulated to store and process data. Another key property is entanglement, where qubits become interconnected, enabling faster computations. Quantum computing has potential in cryptography, material science, AI, and optimization. However, challenges like qubit stability, decoherence, and error correction must be solved before it becomes practical for mainstream use. Antimatter annihilation. Antimatter, the opposite of matter, consists of particles with reversed charges. When it meets matter, both annihilate, releasing immense energy via E=mc². This makes antimatter a potential ultra-efficient power source. To harness it, we must improve production, storage, and energy conversion. Particle accelerators create antimatter, but future laser-driven accelerators could boost output. Since antimatter annihilates on contact, magnetic confinement traps it in a vacuum for safe storage. Antimatter reactors could generate vast electricity, while antimatter propulsion could enable deep space travel. Overcoming production costs and containment challenges could make antimatter power a reality, revolutionizing energy and space exploration. Swarm robotics. Swarm robotics is inspired by social insects like bees and ants, enabling large groups of simple robots to collaborate using decentralized coordination. Each robot follows local rules, but together they perform complex tasks without a central controller. Key advancements include scalable algorithms that allow swarms to adapt dynamically, mimicking behaviors like flocking, foraging, and shape formation. Wireless communication lets robots share real-time data, while bio-inspired signaling improves coordination. Swarm robotics could revolutionize agriculture, disaster response, environmental monitoring, and construction by providing scalable, autonomous, and flexible solutions. Future improvements in AI, communication, and hardware will unlock even greater potential. Programmable matter. Programmable matter is a revolutionary material that can change its shape, properties, or function in response to external stimuli such as magnetic fields, electricity, or light. This concept merges nanotechnology, robotics, and materials science to create dynamic, reconfigurable substances. Innovations include smart materials that self-adjust using microactuators, reconfigurable surfaces for adaptive camouflage, and flexible electronics that self-repair. Future applications range from morphing furniture and temperature-regulating clothing to self-adapting prosthetics and responsive drug delivery. In manufacturing, programmable matter could enable reconfigurable production lines, reducing costs and enhancing efficiency. Smart homes. Smart homes are technology-enhanced living spaces that use Internet of Things (IoT) devices to improve comfort, convenience, and security. These homes integrate devices like smart thermostats, lighting, security cameras, and appliances, which can be controlled remotely via smartphones or voice commands. Modern advancements include AI-powered home assistants that learn user behavior to automate tasks such as adjusting lighting and temperature. Smart security systems now offer real-time monitoring, facial recognition, and anomaly detection for enhanced safety. Future developments may include energy management systems that optimize power usage and integrate renewable energy sources like solar panels. Health monitoring sensors could track vital signs and assist the elderly or disabled. AI-driven personalization could even suggest recipes, plan workouts, and predict household needs, making homes more adaptive and intuitive than ever. Space mining. Space mining is the extraction of valuable resources from celestial bodies like asteroids, the Moon, and Mars. This technology aims to provide materials for space missions and Earth's industries, reducing reliance on limited planetary resources. The process involves robotic prospectors scanning for minerals, followed by autonomous mining equipment extracting and processing materials. Companies like NASA-backed initiatives are developing techniques for efficient space mining.